Hi folks, welcome to this last session of Dev Around the Sun. My name's Jon Skeet, my pronouns are he, him, and you can find me at Twitter on Jon Skeet, that's without an H, just Jon Skeet or at Jon Skeet. Or you can just post a Stack Overflow and I'll probably pick it up at some point. So some of you may have seen Kevlin Henney's fantastic talk yesterday. Well, it was yesterday my time anyway. We'll kind of come back to that around dates, and in particular Java util date, which is just the most fabulous example of design anti-patterns ever. And I thought I'd complement that with a bit of talking about time zones and calendar systems and related stuff. So I give quite a few talks a bit like this, and I tend to start with a slide like this to highlight the different things that we should be thinking about whenever we're writing code to do with dates and times. Because, you know, it's fairly fundamental. If you think about the three most fundamental kinds of data that we deal with in our code, we tend to deal with numbers, and we deal with text, and we deal with dates and times. And yeah, there's binary data as well that's kind of arbitrary stuff. But beyond that, we've got numbers, text, and date time things. And we've screwed all of those up in a talk that I've given in the past called Humanity Epic Fail. Feel free to search for that. But today I'm just focusing on the mess of dates and times. So I typically make the point that we try to simplify things too much in standard libraries, just as Java had Java util date and then Java util calendar, and both of them are terrible. We really need to differentiate between the kind of different concepts that we've got when programming with dates and times. So I start with a slide like that. But today, now, we're not going to go into any of the techie stuff. This is really just a bit of fun. Hopefully there'll be some points that you should learn, mostly in terms of, oh my word, it's terrible. But hopefully a bit more fun than that. So let's start off by talking about time zones. And this is an area where a lot of people have a lot of passionate feelings, let's say, most of which are negative. And I don't think time zones are actually too bad once you get to grips with them. But I do have my own little negative feelings as well. So here's a little mini rant to start with. If you look in the ISO 8601 spec, you'll see, which is for formatting dates and times, really useful to have. Unfortunately, they say, oh, the zone identifier or something like that can be of the form +1:00. Now, that's not a time zone. If you say, oh, my time zone's PDT, that's not a time zone. If you say my time zone's CST, that's even worse, because that could mean Central Standard Time in the US. It could mean Central Standard Time in Australia, or it could mean Central Summer Time, also in Australia. So, you know, two things here. Separate the concepts of an offset from UTC, that's like the +100 here, not a time zone, but a useful thing. And then three-letter acronyms for things that aren't time zones. Just say no. And picking on Australia here for the having Central Standard Time and Central Summer Time, yeah, the UK is just as bad, which I'll come to in a bit. But no, a time zone is, broadly speaking, a region of the planet that has always and will always, as far as we know, share the same idea of what is local time. And even that's a little bit woolly, because you can have two places that, for all of the time that you're interested in, have shared a local time. But maybe back in the 1830s, they had different times. And maybe you say, okay, well, they're the same time zone as far as I'm concerned, even though in some other application, they might be different time zones. It's already kind of tricky. Most of this talk is going to be around amusing aspects of trivia, let's say. Things that will scare you into not wanting to ever deal with time zones and calendar systems again. And we'll start off with an innocent sounding date and place, December the 30th, 2012 in Samoa. Which sounds great, but it didn't exist, because Samoa decided to change their time zone. They were in the same time zone, but change what that time zone meant to cross the international date line. They went from one side of the international date line to another by moving the international date line. They didn't actually start moving bits of land, which means that if you say, I wish to schedule a meeting, or back in 2010 or something, I wish to schedule a meeting for midday on December 30th in Samoa. Like, yeah, that just didn't happen. We skipped straight from December 29th to December 31st. That's kind of fun. It's always an interesting little test for a date and time API. You can usually ask date and time APIs, well, what's the offset at this particular point in time in a particular time zone? See what they say for Samoa. Some date and time APIs will let you say, well, what was the offset at midnight? Well, that didn't exist in Samoa. You could say, what's the start of the day? And that didn't exist in Samoa either. So yeah, it's an interesting little corner case. It's not entirely unique, but there aren't very many of them. But let's go to a better understood, something we're all familiar with, the Unix epoch. So the Unix epoch is defined in terms of, well, I'm not going to go into leap seconds, but let's say 1970 UTC midnight, 1st of January. Order those however you want. 1970 January 1st midnight UTC would be the more normal way of doing things. Now you might say, that's fine. That's midnight UTC, sorry, midnight 1970 January 1st in Greenwich. And that's where you'd be wrong, because even though you might think Greenwich observes GMT, well, GMT, like BST and CST, is not really a time zone, but it is roughly equivalent to UTC. It's expected to be equivalent to UTC, but Greenwich isn't always on Greenwich Mean Time, because Greenwich is in London, and the Europe-London time zone spends half of its time observing GMT and half of its time observing BST, British Summertime. Except during a period in the late 1960s, early 1970s, where the UK decided to go on a little experiment. It decided that it would abandon daylight saving time, which is a move I kind of support, but it would observe BST, where BST didn't mean British Summertime anymore. Oh no, it meant British Standard Time, which still had the same UTC offset as British Summertime. It was UTC +1, but wasn't observing daylight saving time. So actually, at the Unix epoch, if you were in Greenwich, it would have been 1 in the morning. So speaking of oddities around midnight, let's talk about Brazil and Iran and some other places. And I have to give a little bit of history here that this oddity is what first got me really interested in daylight saving time and time zones and calendar systems to start with. I used to be working on the Google mobile sync for calendars. So back when iPhones were relatively new, I think this was before the first public release of Android, I was writing code to use the ActiveSync protocol, so from Microsoft, to synchronize calendars on iPhones with Google Calendar. So it's sort of the big 3 technology platforms, and you can imagine that they all just hook up nice and no problems at all in terms of standardization. Who are we kidding? So there are things in Google Calendar of all-day events, and as far as I'm aware, back then they didn't exist in ActiveSync, so we had to work out how to represent it. You do an all-day event by saying it's midnight to midnight, right? That sounds like it makes sense, and most of the time that's fine, until I came into work one morning and found there were a load of exceptions in my logs, like loads of them, all in Brazil, because we'd been trying to synchronize all-day events for a day which didn't have a midnight. How could it not have a midnight? Well, partly that depends on your definition of midnight, of course. We all think we know what midnight means, but it can mean different things depending on exactly how you define it. If you define it as the instant at which the next day starts, then that's fine. If you define it as 12 o'clock in the morning at the start of a day, not so much. because Brazil, when it does a skip forward in its spring, which is in September, October, they go 11:59 p.m., 1 a.m. They skip the hour between 0000 and 0100. So aside from anything else, at this point, having just seen a little message on the chat saying about this call being 24 hours or a 24-hour conference, aren't we glad that we didn't organize Dev Around the Sun at a time when time zones were switching from one rule to another in at least some time zones? Like, that would have been just a nightmare. Anyway, so Brazil skips forward at midnight to 1 o'clock in the morning, and then when it does a fallback in what is spring in the northern hemisphere and fall in the southern hemisphere, it goes back from 1 in the morning to midnight. So midnight happens twice in Brazil's fall. Take Tehran in Iran, for example. That has a slightly different but equally annoying thing of they skip forward, so they go 10:59:59, then goes to midnight. So they do always have at least one midnight, but they also fall back to midnight. So they go from 1 in the morning back to midnight. So that's all according to the IANA time zone database. And that's where Windows ends up being a little bit different. Because the IANA time zone database for, I think, both of the time zones I've been talking about in Brazil and Iran, expressed this as the change is at 24 o'clock. Pretty sure it is for Brazil anyway. Iran wouldn't make as much sense on that. But Brazil, it moves at 24 o'clock on the second Saturday or whatever it is. Now, 24 o'clock on the second Saturday isn't the same as midnight on the second Sunday, because if you get a year where where Saturday and Sunday go over a month boundary, stuff goes all kinds of haywire. So you can't represent a time zone rule of 24 o'clock on a Saturday as midnight on a Sunday. So the Windows folks are very aware of that, but the Windows representation of a time zone has, this is the time it happens, and that's got to be a valid time, and 24 o'clock is not a valid time. So tell you what, let's just represent it as 23:59:59.999, which means that for these time zones, when they would change at midnight, they actually change 1 millisecond earlier. Now, you may think that, what's a millisecond between friends? It's really not going to be a problem. I worked on a bug in my Node-time date and time API on this just last weekend or the weekend before. I get my weeks muddled these days, as we all do. Because if you're trying to say, well, what date does that fall on? Well, it's an entirely different day. So that's just one of the oddities around the Windows time zones. Generally, I would recommend using the IANA time zones if you can, and obviously Node-time if you're using .NET. Well, 24 o'clock, okay, has some problems, but we know how to handle it. That's not the worst it can be. 24 o'clock, you're only going to be wrong by a millisecond. What if we had a 25 o'clock? Transition at 25 o'clock? Now that sounds fun. Yeah. This actually happened. Back in 2018, the IANA time zone database changed to better reflect reality. Reality in Japan between 1948 and 1951, this is. So we're talking, nearly 70 years, it was 70 years later, rectifying the time zone database to be more correct. Because the legislation for Japan in those 4 years, 1948 to 1951 inclusive, said we're going to skip forward at midnight and we're going to fall back at 1 in the morning. But actually not 1 in the morning, but 13 p.m. on the Saturday. So if you were just sort of doing things the obvious way, yes, it would be 1 in the morning on the Sunday. But no, it counts as 25 o'clock on the Saturday, which means that 12:30 p.m. on Saturday, September the 11th in 1948 in Tokyo is ambiguous between two instants that are 12 hours apart, because we don't really have a 12:30 p.m. the second time, ppm. So unambiguously, that would be 12:30 or 24:30. Have fun. Well, you might be asking how this could possibly matter. Suppose you were born at 24:30 on Saturday, September the 11th in 1948 in Tokyo. That changes your birthday. If computer systems get that wrong and say you were born on the Sunday, that could affect whether you can vote. It could affect when you get a pension. It could affect all kinds of things. I should ask yourself, how does your system, whatever programs that you're developing, cope with that? Can you, if you register someone's birthday with the time, do you allow them to put 24:30 in? My guess is most don't, and I have to confess, Know the Time doesn't either. Finally, on time zones, I just want to mention the silver bullet that I hear a lot, which is, let's just store UTC. Everything will be fine if you store UTC. And sometimes that's right, but not all the time. Suppose we are writing an event scheduling system, and we think, okay, in 3 years' time, the lockdown is over. So I will schedule a date with my wife, Holly, on my birthday, June the 19th, in 2023 at 9 o'clock in the morning in a cafe in Paris. Sounds delightful. We can have huge cappuccinos. It'll be lovely. Okay, so suppose I'm on a system that stores UTC. I work out what instant in time, 9 o'clock in the morning, 2023, June 19th, etc., in Paris. And I store that UTC. I store that instant in time via UTC. All sounds well. Now, there's some legislation that has been going through the European parliaments, and it's sort of still up in the air as to whether Paris will still have daylight saving time in 2023. Maybe it won't have daylight saving time, but will be on permanent UTC +2, which would be fine, because that's what we would predict it to be now. Or maybe it will be on permanent winter time, as it were, so always on UTC +1. At that point, the date that I've arranged with Holly wouldn't be at 9 in the morning if we just stored the instant. It would be at 8 in the morning. That's a bit early for a breakfast date, even. If you store what you actually know from the user, they want it to be at 9 o'clock, then you can always handle changes in time zone data if you're really careful about it. If you just store the instant, you have lost information. I've written much more about this. It's another of my ranty subjects. If you search for storing UTC is not a silver bullet, you'll find probably more information than you ever want. But the important thing is, if people say time zones are easy, just store UTC, then feel free to send them in my direction. So that's all for time zones. And you might be thinking that's already kind of hard enough, broken enough. But what about calendar systems? So far, everything I've described has been in the Gregorian calendar system that most of the world uses for most things. But there are lots of other calendar systems around, and they're quite separate from time zones, other than time zones are usually expressed, their rules are expressed in terms of Gregorian calendar. And you can start by thinking that calendar systems are just ways of breaking the span of time into days, months, and years. And then you have to think about calendar systems where the day starts at sunset. Well, what does that mean? Does that mean that it changes when the day starts, even within the same time zone, based on, if you have a particularly wide time zone where the sun might set half an hour earlier in one point than in another, does the day start differently for the same? Oh, I get very confused. So even most good date and time APIs ignore the whole sunset thing. But we do still need to think about how do we represent what's a year, what's a month, what's a day of month. And what always amuses me about this is probably where religion hits computing most. You might think that your coding, we have religious wars about tabs versus spaces and things like that, brace positioning. But actually, the religious aspect that affects computing most is whenever we're doing date and time things. We have the Gregorian calendar system. That's Pope Gregory. We have all kinds of other calendar systems which are based on a culture which, certainly in the distant past, used to really be affected by the religion that you were in. Again, some more trivia just to make you not want to deal with any of this. The first one of these, I nearly took out because Kevlin told us about this yesterday. However, it's just too good to miss. So, as an introduction, most of Europe used to observe the Julian calendar system, which had leap years every 4 years, like clockwork. And these days, we mostly observe the Gregorian calendar system, which is a leap year every 4 years, except when it's a 100-year boundary, except it is when it's a 400-year boundary. Different countries went from the Julian calendar system to the Gregorian calendar system in different times. And in fact, in some countries, they kind of did a calendar hokey-cokey going, we'll go with the Julian calendar, Gregorian calendar, Julian calendar, Gregorian calendar. I don't know how the populations coped. Sweden decided that they would skip not in one day like most people did. They would go gradually by just not having any leap years for a long time. And so in 1700, they didn't have a leap year. Great. And then they got into the Northern War and they basically got distracted. So they forgot in 1704 and 1708 that they weren't meant to have leap years. And so in 1709, they were just 1 day out of sync when they should have been 3. So they decided, oh, we'll scrap it all, go back to the Julian calendar system for a while by having a double leap year. So they had a February 30th in 1712. And then they switched over properly in 1753. Now, in case anyone thinks that I'm being slightly mean to Swedes, I should say Great Britain has its fair share of oddities. We moved to the Gregorian calendar system in 1752. September the 2nd was followed by September the 14th. We skipped 11 days. That means the year beginning in 1752 was the shortest year in British history, as far as I know. But it didn't have just 353 days. It had 282. It started on March 25th and ended on December 31st. Kevlin mentioned that years used to start in March, but why March 25th? Well, it's quite close to the vernal equinox, and there's some history around that. And in different places, different cultures started the year in different months. So back in Mesopotamia in 2000 BC, they started the year in spring. And Julius Caesar made it January the 1st in 46 BC. Then in the Middle Ages, that was abandoned and they went back to, well, March the 1st or March 25th or December 25th. And March 25th and December 25th are both kind of religious dates because December 25th, Christmas, Christ's birth. March 25th, 9 months before that, the Annunciation. Now, I was going to mention why the British tax system starts on April the 6th, because I thought I knew, and then I read the Wikipedia article. It's so confusing I had to go and lie down. I'll finish with just one other calendar system. I have a few more up my sleeve, but I'm just going to finish with the Hebrew calendar system. And just as a disclaimer, this is in no way meant to be an attack on Judaism or Jews or anti-Semitic at all. But the Hebrew calendar system provides its own interesting aspects. So it doesn't have leap days. It has leap months. A year has either 12 or 13 months, depending on, well, even that depends. It used to be observational. So when the final month of the year, Adar, was over, they would decide, well, do we want to start a new year yet, or should we add an intercalary month? And they used to say, okay, we'll have an intercalary month based on 3 different criteria. One was how ripe the barley was, one was how ripe the fruit were on trees, and one was the equinox. And if 2 of the 3 conditions were met, then they would add another leap month. So you can imagine trying to schedule your Skype calls back then was just really tricky. These days, it's calculated rather than observational. But trust me, if you think that getting leap years right is tricky in the Gregorian calendar system, have a look at the Hebrew calendar system sometime. It's really, really tricky. Even just, is it a leap year, is slightly tricky. Of different lengths depending on all kinds of things. It's really, really horrible. But coming back to this extra month, you might think that it's easy to tell whether you're older or younger than someone. So if I'm going to be 44 shortly, and someone else might be 43, that means that I'm older than them, right? Yeah, not necessarily. So in the Hebrew calendar system, this extra intercalary month is called Adar 2. So we have Adar 1 and Adar 2. Now, suppose I am born on the 20th of Adar 1 in a leap year. And suppose you, dear listener, are born on the 10th of Adar 2 in the same year. Okay, so I'm 20th of Adar 1, you're the 10th of Adar 2. You were born after me. That means I'm older than you, right? In a non-leap year, we've only got 1 Adar. So when do we celebrate our birthdays? I would celebrate mine on the 20th of Adar. You would celebrate yours on the 10th of Adar, which is 10 days earlier. Do you say that you're a year older at that point? In which case you could be 44, and I could be 43, even though I'm older than you. I really, really hope that has broken your head somewhat. I will leave you with a little bit of actual tech advice. So this is last 30 seconds of the talk. So you could read this, or you could just switch to a new tab and get busy donating to Direct Relief. In particular, I'm going to be shameless now. If I have ever helped you on Stack Overflow, if I've saved you half an hour, then why not donate 10 minutes worth of salary to Direct Relief right now? And I feel utterly shameless, but it's in a really good cause. So anyway, I hope you have enjoyed Dev Around the Sun. Please give generously, and handing over now to Claire and Dylan.